Okay, my name is Filip Špoljar, and I'm a lead data scientist at Acquaint. Today I will talk about how we created an Amenity Recommender in the hospitality industry that is used for predicting guest interests. In Acquaint, we actually created the whole solution. The solution for hospitality industry that is up and running. It's in production in one hotel chain, and the solution have of course the front end, back end, and the actual recommendation engine. We integrated it with some CRM software. We have proof of concept with Amazon Alexa. We're integrating it currently with IPTV and so on. I will not talk about the entire solution. I will focus today on machine learning parts. So first, I will tell you a short story about Acquaint, then why we even need the Amenity Recommender in the hospitality industry. Then I will talk about our ensemble of models that's predicting guest interest, and some other techniques that are not directly predicting guest interest, but they are helping us to achieve better accuracy of our models, and some final notes as an overview of our experience so far. So Acquaint was founded early this year in January, so we are a very young company, and we call it ourselves the first truly data science company in Croatia. It's not quite true. There are other, I suppose there are other data science companies in Croatia, but we are definitely among the first ones, and we are actually very proud of it. We tend not to be an IT company with data science division. We tend to be a data science company with an IT division that's actually helping us to wrap our products that we can later offer our clients. We are focused on the hospitality industry, and we are helping the industry with our knowledge of IE to solve their problems. So why do we even need an Amenity Recommender in the hospitality industry? There are some standard ways and usual ways in the hospitality how can they increase hotels' revenue. For example, they can increase capacity, but this technique requires significant capital expenses. They can also increase occupancy, but it's very dependent on the seasonality and requires substantial operating expenses. And of course, there is a increase. They can always increase prices of their rooms, but you don't actually know how your guests will react. So we offer a solution that's cost much lower, and it's in the shape of the Amenity Recommender. And what it's actually doing, it's boosting on-property upsell. It's boosting internal hotel sell, actually. We are recommending internal hotel products like wellness, multiple wellness treatments, sports activities, restaurants, and everything that's within the hotel. And we are targeting directly the total guest value. Total guest value is a hospitality term that includes all the spendings that the guest, all the guest spendings during the entire stay. And we are directly increasing the total guest value. We are, of course, personalized because we use features from the guests like their age, country, the company, if they are here with the children or with the wife. And we also use some external variables, external features like weather forecast, month of stay, and similar. You're probably asking and assuming that we are just another company that has recommendation engine, and that we implemented content-based filtering, collaborative filtering, and we have our recommendation engine. You are partially true, because we have a recommendation engine, but we cannot use this let's say, basic recommendation algorithms. And why is that? It's because we don't have such data. We don't have history. For example, Netflix, when you have a recommendation engine, it's more complex than that, but when you have a recommendation engine on Netflix, you have lots of history of one user, maybe 50 movies per month. And we have only 5% of our entire data set, only 5% are returning guests. So you have a little history of them. We are using that for some other recommendations, but in our models, the history is we cannot use for comparing our guests in products based on the consumption history. What we do, we created our own hierarchical structure, and first we had only products, and with those products we couldn't do actually anything. Nothing, because we could make a multi-classification algorithm and pick top 3 products and push that as a recommendation. And of course, it didn't work. So what we did, we grouped the products into subgroups, and we grouped the subgroups into larger groups. And on each mentioned stage, we have different algorithms, different binary classification, multi-classification algorithms. And of course, on each stage, we have different amount of data. On the first stage, we have a large amount of data, and how we, in the below levels is of course increasing. But as an example, on the lower level, on the product level, you must choose or decide whether to offer a guest excursion to one island or another. That's type of product. But in that moment, you already know that your guest is interested in excursion, that your guest is interested in excursion with a boat, and you only need to choose if send him, let's say, to one island or another. So if you miss an island, it's not a big deal. It's a big deal if you miss a whole group of products, but at the product level, we are fine with it. Let's start. We, of course, dropped the missing values because we needed to do MVP actually. But we knew that we must somehow impute missing values, and I will just explain a basic way how we are researching and what algorithm do we use to impute missing values. For example, it's a simple autoencoder neural network. We all know how encoders do. You have an input of, here you have 5 features, and it compressed those 5 features to only 2. And the other side you have a decoder that's as input is using compressed vector, and the output you will get not the original data, but the whole mechanism is introducing some loss. So how we use this for imputing missing values? You actually, for example, age. If you have a missing value for age at start, in the encoder you are imputing the average age for all your guests, and on the other side you will have the predicted imputed value. It's very simple. For our case, it was very effective, but with the flow, it doesn't work well with categorical variables. We need to think. We need to explore something different for our categorical variables. The next thing, we need to solve our cold start problem, as well as we have problems with products that are not usual. For example, excursion to Venice with a plane. If you are on Croatian sea coast, how many people per year will go to excursion with a plane to Venice? I don't know, around 15. So you cannot make a prediction based on just a few data points. So what we are researching and trying to accomplish is to generate fake data. So this is the example of generative adversarial networks, where I will explain this in a much simpler way. Imagine that you have a criminal that's faking money, and you have a policeman that's trying to distinguish are the bills fake or real. And in the first iteration, the criminal is just writes the $10 on a piece of paper, and of course the policeman knows it's fake bill. But after some iterations, the criminal has improved his technique, and he's able to simulate the real bills, and the policeman is having trouble to distinguish between real and the fake. And also discriminatory is learning, it's improving his technique, and they are always competing. So in our case, and the basic parts of the GAN are the generator, that's the criminal, of course, and we have discriminator, that's the policeman. And generator is generating fake guests, and we use that fake guest as an input to our models. Also, we are sort of satisfied with the GAN, but we are also having troubles with categorical variables. It's also very hard to verify the result of GAN, and it's very hard to train. For example, if you have image and you use GAN to generate images, you can verify the result. You have the image as the result, and you know when to stop. But when you have feature vector of 20 features, you actually don't know where to stop. So what we are currently doing, we are extracting some variable features, for example, room type or age or gender, and then on all the other features we are using the PCA, the dimensionality reduction technique, and visualize those data so we can decide, are we good enough are the fake data set good enough for using it in our models. Last thing is embedded vectors. I mentioned that we had problems and still have problems with categorical variables. So there is a simple and effective technique that's actually help us to increase our accuracy. So what's behind the embeddings? You have a categorical variable, for example, room type, and you must encode it. You can use label encoding, binary encoding, one-hot encoding, and all these techniques are actually one-dimensional. So over here we have example of label encoding, where you have, for example, presidential suite, and you give it a label 20. You have Deluxe Seaside. What label to give to Deluxe Seaside? Maybe 10. Is the Superior Seaside closer to Deluxe Seaside or a luxury suite? You don't know that. You can, and we define this with, of course, the main expert, but it's not good enough. So what we did, we introduced in our neural networks embedded vectors, and from embedded vector you get this. You get, instead of one dimension, you get four-dimensional vectors, and you can compare all these room types in 4 dimensions. It's actually improved our final accuracy. So actually that's all. When I talk to my colleagues and tell them what we do, they always ask me, why don't we use an AI platform? It's because not that they are not good enough, they are built by very, very smart people, but we want to learn, we want to know how each algorithm that we are using is working under the hood. We are, of course, using the standard libraries like scikit-learn, TensorFlow is similar, but we want to make these tailor-made modifications to hyperparameters to our recommendations so that we can actually get the tailor-made recommendations at the end. It is not an easy path to take because there are many undocumented libraries. There are snapshots, they are not released. It's very frustrating when they change the API between patch version. You don't expect that. It's very annoying, but it's challenging and demanding, and actually we are enjoying it. So, thanks.